When were you born? Sounds like a simple question. You just say a certain year, month, and day. But around the world, we reckon time differently. In Saudi Arabia, it's the 15th century. In Israel, it's the 58th. And we live in 24 different time zones. We all measure time relative to some starting point, a point we have chosen. But if we really want to know what time it is, we need to know when the cosmic clock started to tick.
In the infinite stillness of space, far beyond the glow of city lights and the noise of human life, lies a boundless ocean of stars. This ocean, invisible to the naked eye, yet always above us, stretches farther than imagination can reach. It is not water that fills this ocean, but light, the soft shimmer of billions upon billions of suns, scattered like dust across the black canvas of the universe. These immense islands of stars, dust, and gas are called galaxies. Each one drifts in the silence of space, a living structure that has existed for billions of years, slowly spinning, shining, and changing in ways that almost seem to breathe. Galaxies are the great cities of the cosmos. They are where stars are born, live, and die. Some are vast and bright, others small and dim. Some are shaped like elegant spirals, others are smooth and oval, and a few are chaotic and irregular, as if shaped by chance. Yet all of them, no matter how different they appear, share one story, the story of light and gravity, dancing together in the deep silence of time. The word galaxy comes from the ancient Greek phrase galaxias kyklos, meaning milky circle. Long before telescopes, people saw a faint milky band stretching across the night sky, the Milky Way. They thought it was a mist, or perhaps a path of spilled milk from the gods. They could not have known that what they were seeing was a vast collection of stars, so far away and so densely packed that their light blended into a soft white glow. Today, we know that the Milky Way is just one of many galaxies, perhaps 2 trillion or more, each with its own stars, planets, and mysteries. Imagine yourself floating through the emptiness between galaxies. There is no sound here, no wind, no echo, only stillness. From this distance, each galaxy looks like a distant, glowing whirlpool. If you look closer, you'd see billions of individual stars, each one possibly with its own solar system, its own planets, perhaps even life. And yet, the distances between these galaxies are so great that even light, the fastest thing in the universe, takes millions of years to cross from one to another. Galaxies come in different forms. The most beautiful and familiar type is the spiral galaxy, a flat, rotating disk with arms that spiral out from a central bulge. The Milky Way is one of these. The arms are not solid structures. They are waves of density, where stars and gas gather more densely, forming clusters and nebulae. If you could look down at the Milky Way from above, you would see glowing lanes of blue and white stars, tracing elegant spirals through the darkness, dust clouds painting shadows across the light. Then there are elliptical galaxies, giant balls of older stars, smooth and almost featureless. They are the elders of the cosmos, filled with ancient suns that no longer form new stars. Some of these ellipticals contain trillions of stars, making them among the largest structures known. They glow with a soft yellow hue, the light of aging stars that have burned for billions of years. And finally, there are irregular galaxies, chaotic, shapeless, often born from collisions between others. They look like broken clouds or fragments of spiral arms scattered in space. These irregular galaxies are where star formation often bursts into life, triggered by the violence of cosmic encounters. Though they seem messy, they remind us that beauty in the universe is not always symmetrical. Every galaxy is a balance of gravity and motion, Gravity pulls stars toward the center, while their motion keeps them from collapsing into it. It's the same principle that keeps the Earth orbiting the Sun, but on a much grander scale. Galaxies spin, not in a rush, but with the slow patience of eternity. Our Milky Way completes one rotation roughly every 230 million years. When dinosaurs first walked the Earth, our solar system was in a completely different part of the galaxy. If you were to stand on a planet in another galaxy and look at the sky, you would see something very different. The night would glow with the light of millions of stars packed more closely than in our skies. Nebulae might stretch across the heavens, painting the dark with color. The nearby galaxies could appear as bright clouds. It would be a night of endless wonder, and perhaps a reminder of how small we are in the face of such vastness. Yet galaxies are not silent in their birth. They begin as small ripples in the early universe, born from clouds of gas and dark matter. Tiny fluctuations in density, billions of years ago, grew slowly under the pull of gravity. Hydrogen gathered, stars ignited, and galaxies took shape. Over time, they merged, collided, and evolved. Every galaxy we see today carries scars of those collisions, stretched arms, warped disks, twisted rings, all silent witnesses to ancient cosmic events. In the heart of almost every large galaxy lies a supermassive black hole. These giants weigh millions or even billions of times more than our sun. Though invisible, they shape everything around them. Their gravity governs the orbits of nearby stars and can power quasars, the brightest objects in the universe, when matter falls into them. Yet, despite their power, they rest quietly for most of their existence, surrounded by stars that continue to circle in peace. Galaxies do not live alone. They travel in groups, clusters, and superclusters, vast webs of galaxies connected by the invisible threads of dark matter. The Milky Way belongs to a small cluster called the Local Group, which includes the Andromeda Galaxy and about 50 smaller galaxies. These clusters form part of an even larger structure known as the Laniakea supercluster, which stretches hundreds of millions of light years across. Beyond that are other superclusters, and beyond them, more an endless tapestry that fills the observable universe. The more we look, the more we realize how many galaxies there are. With the Hubble Deep Field and later the James Webb Telescope, astronomers pointed their instruments at a small, seemingly empty patch of sky and found thousands of galaxies packed into that single image. Each one contained billions of stars. It was like finding an ocean hidden in a drop of water. Some galaxies are active, bursting with light and energy. Their centers glow so brightly that they outshine all the stars combined. These are called active galactic nuclei, powered by the feeding of their central black holes. When matter spirals into the black hole, it releases enormous energy, sometimes creating jets that shoot across thousands of light years. Even from unimaginable distances, we can see their faint flickers through telescopes, whispering across the universe. Other galaxies are quiet, their light soft and dim. They no longer form stars, and their energy fades slowly over billions of years. Someday, even our galaxy will grow old and dark, as stars die and no new ones are born. The universe will continue to expand, carrying galaxies farther apart, until their light can no longer reach one another. But for now, the sky still glows with their beauty, a gentle reminder that creation is ongoing. What is perhaps most humbling is realizing that everything we know, every star, planet, and atom, is part of this galactic story. Our sun is just one of hundreds of billions of stars in the Milky Way. Each star may have planets, and each planet may hold oceans, mountains, or perhaps even life. Yet from afar, all of it merges into one faint glow. When you lie under a dark sky and look up, you are seeing only a tiny fraction of what exists. The Milky Way band that arcs overhead is a mere slice of our own galaxy. Beyond that lie countless others, and beyond those, more still, stretching into infinity. Every point of light in the night sky has its own world, and every world has its own story. There is peace in knowing that the universe is vast beyond comprehension. Its age, its scale, its beauty, all of it reminds us that we are part of something eternal. Galaxies are not just distant objects of study. They are the cosmic gardens that made us possible. The atoms in your body were forged in stars that once belonged to galaxies that may no longer exist. We are, quite literally, made of galactic dust, fragments of long-dead stars carried through time to form new life. So as you drift into sleep, imagine yourself floating through this silent ocean of stars. Picture the glowing spiral of the Milky Way turning slowly beneath you. Imagine billions of galaxies shimmering like distant lanterns, their light gentle and ancient. Feel the quiet pull of gravity that connects everything from the largest galaxy to the smallest atom. In the endless dark, you are surrounded by the quiet hum of eternity. There is no hurry, no noise, only the rhythm of the cosmos, the slow breathing of galaxies, the gentle swirl of stars, and the soft light of creation stretching endlessly ahead. And somewhere, out there in that ocean of stars, another being may be looking up, seeing the same sky and wondering the same thing. How beautiful, how vast, and how peaceful this universe truly is. As the stars drift farther apart and galaxies continue their slow dance through time, one truth remains unchanged, that in the stillness of the night, surrounded by the light of a billion suns, there is serenity. A serenity so deep, it carries the heartbeat of the cosmos itself. In this vastness, you are both small and infinite, fragile yet eternal. A whisper of stardust among galaxies, resting quietly in the calm ocean of the universe. The Milky Way, our home in the dark. A vast, spiral galaxy shimmering silently in the cosmic ocean, like a glowing whirlpool frozen in time. It stretches 100,000 light years across, and at its heart lies a powerful secret, a black hole known as Sagittarius, a asterisk. Yet from our small world, drifting on one of its arms, we see only a narrow glimpse, a pale river of light arching across the night sky. This is our galaxy, our cradle, our ancient home among billions of others. When you step outside on a moonless night and look up, far from city lights, what you see as the Milky Way is just a fragment of the great spiral disk that holds hundreds of billions of stars. Each one is a sun, and many of them may have planets of their own. To the naked eye, it appears as a faint mist, but through a telescope, it bursts into countless pinpoints of light. The soft haze turns into a glittering landscape, a reminder that even in darkness, the universe is alive with brilliance. The Milky Way is shaped like a vast spiral disk, with long curved arms winding outward from a bright central bulge. It spins slowly, one full rotation taking about 230 million years. Our solar system lies about 27,000 light years from the center, on a quiet spiral arm known as the Orion Arm. We orbit the galactic core at a speed of about 828,000 kilometers per hour, fast enough to circle the galaxy many times over cosmic history. And yet, from our view on Earth, we feel nothing but stillness. Our galaxy is not alone in the cosmos. It belongs to a small neighborhood called the Local Group, a family of more than 50 galaxies held together by gravity. Among them are the Andromeda Galaxy, our nearest large neighbor, and the two Magellanic Clouds, irregular dwarf galaxies visible from the southern hemisphere. Together, they drift through space like companions in an endless journey. If you could step outside the Milky Way and look back, you would see a magnificent spiral of glowing light. Young blue stars would trace its arms, while older, Yellow stars would cluster near the center. Dark bands of dust and gas would thread across the disk, absorbing light and creating the shadowy patterns we see in our night sky. From this vantage point, our sun would be almost invisible, just another small spark in the sea of starlight. Deep within the core lies Sagittarius A*, a supermassive black hole, about 4 million times the mass of our sun. It rests quietly most of the time, occasionally flaring as it consumes nearby gas or dust. Its gravity binds the orbits of millions of stars near the center, keeping the galaxy's heart in balance. If we could see it directly, it would appear as a dark void surrounded by glowing rings of superheated matter, an endless swirl of energy and silence. The Milky Way didn't always look the way it does today. Billions of years ago, it began as small clouds of gas and dark matter merging together. Over time, gravity drew them into larger structures, forming the first stars and clusters. Collisions with smaller galaxies reshaped it, stretched its arms, and added new stars. Even now, the Milky Way continues to grow. The Magellanic Clouds, slowly being pulled apart by its gravity, leave trails of stars and gas, cosmic breadcrumbs marking their path through space. The night sky holds quiet evidence of our galaxy's vastness. When you see the constellation of Sagittarius, you are looking toward the galactic center. In the opposite direction, toward the constellation of Perseus, lies the outer edge of the disk. Between them, countless stars, nebulae, and star clusters fill the space too many to count, too distant to fully see. Astronomers use radio waves, infrared light, and X-rays to map what our eyes cannot: the spiral arms, the dense dust lanes, and the hidden heart of the galaxy. Within the Milky Way, new stars are constantly being born. Massive clouds of hydrogen collapse under gravity, igniting nuclear fusion that brings new light to the cosmos. These star-forming regions glow with soft colors pink and blue nebulae scattered through the spiral arms. One of the most famous is the Orion Nebula, just 1,300 light-years away. Here, young stars emerge from swirling clouds, their light pushing away the gas that created them. It is a living process, a cosmic cycle that has continued for billions of years. While new stars are born, others reach the end of their lives. Some fade gently, turning into white dwarfs that cool slowly over time. Others die violently, exploding as supernovae that scatter heavy elements into space. These elements, carbon, oxygen, iron, become the building blocks of planets and life. Every atom in your body was once part of a star that lived and died within the Milky Way. You are, in every sense, a child of the galaxy. Around many stars, planets orbit quietly. Astronomers have discovered thousands of exoplanets in our galaxy, and they estimate there could be more planets than stars. Some are gas giants, some are rocky like Earth, and others may orbit in the habitable zone, where conditions could allow liquid water and perhaps life. In the vast sweep of the Milky Way, there could be countless worlds, each with its own sky, its own story, and perhaps its own beings looking up and wondering who else is out there. The Milky Way also carries traces of its violent past. Astronomers have found streams of stars arcing through its halo remnants of ancient galaxies torn apart by gravity. These star streams tell the story of collisions and mergers that shaped our home. Each one is like a fossil record in space, preserving memories of cosmic encounters billions of years old. The disk of our galaxy is not perfectly flat. It is slightly warped, twisted by the gravitational pull of nearby galaxies. From afar, it would look like a vast spiral leaf, its edges gently curling upward. This warp moves slowly, changing over time, another rhythm in the long pulse of the cosmos. Beyond the visible disk lies the galactic halo, a faint sphere of stars, globular clusters, and dark matter that surrounds the Milky Way. It stretches far beyond what we can see, enveloping the galaxy in an invisible cloud of mass. This halo helps hold the galaxy together, its gravity binding the outermost stars to the whole. In about 4 billion years, the Milky Way will meet Andromeda. The two galaxies are moving toward each other at about 400,000 kilometers per hour. When they collide, they will not crash like solid objects, but pass through one another, their stars barely touching. Gravity will twist their shapes, flinging stars into new orbits and triggering waves of star formation. After billions of years, they will merge into one enormous elliptical galaxy, sometimes called Milkomeda. The night sky of future Earth, if it still exists, will glow with new light as two galaxies become one. But for now, the Milky Way drifts quietly. Its stars orbit in patience. Its nebulae shimmer in silence. Its black hole sleeps in the center. From our small planet, we can only watch and listen to the faint light that reaches us across thousands of years. It is ancient light. Some of it began its journey long before humans walked the earth. As you close your eyes and let your thoughts drift, imagine floating above the disk of the Milky Way. Beneath you stretches a spiral sea of stars, glowing softly against the dark. Faint clouds of dust weave patterns through the arms. Every spark of light below is a sun, perhaps with its own family of worlds. The galaxy turns slowly, silently, endlessly, a motion so vast you cannot feel it, but it carries you nonetheless. Feel the calm of knowing that you belong to this great structure. Your world, your life, your breath, all are part of the same cosmic pattern. From the smallest atom in your body to the largest star in the galaxy, everything is connected by the same laws of gravity and light. The Milky Way is not just our address in space. It is our story written in the stars. It tells of birth and death, of time and motion, of endless cycles of creation. It whispers through the night sky, reminding us that no matter how far we travel or how much we learn, we are always home, drifting together in the dark sea of the galaxy. And as the stars spin slowly around the galactic heart, time stretches out beyond measure. Nothing here is rushed. Nothing is loud. It is all quiet, graceful, and eternal, a cosmic lullaby that hums softly across the ages. You are part of that song, a small note in the grand melody of the Milky Way. And as you fall asleep, the galaxy continues its gentle turn, carrying you through the vast silence of space, your home, your light, your endless sky. The heart of the galaxy, Sagittarius A**. It rests in the silent center of the Milky Way, hidden behind thick clouds of dust and gas. Though invisible to human eyes, its presence is undeniable. Here, gravity rules with absolute authority. Nothing escapes its pull, not even light itself. This is the supermassive black hole that anchors our galaxy, a dark engine that has shaped its motion and destiny for billions of years. It is both destroyer and creator, a paradox wrapped in silence. At the very core of our galaxy, in the direction of the constellation Sagittarius, lies this extraordinary region. It is crowded with stars, nebulae, and dense molecular clouds, all swirling under immense gravitational influence. Astronomers call it the galactic center, a realm so energetic that radio waves, X-rays, and gamma rays stream from it constantly. Yet, to the naked eye, it remains hidden behind veils of interstellar dust. If you could somehow remove those clouds and look straight into the center, you would see chaos stars whipping around at unimaginable speeds, bright gas spirals falling inward, and the invisible maw of Sagittarius at times at the center of it all. This black hole has a mass of about 4 million suns. To imagine it is almost impossible. Its event horizon, the boundary beyond which nothing can escape, is roughly 24 million kilometers wide, about the size of Mercury's orbit. But despite its vast mass, Sagittarius A times is tiny compared to the galaxy it governs. The Milky Way stretches 100,000 light-years across, and yet all of it, every star and planet, slowly moves under the influence of this central point. In 2022, for the first time, humanity captured an image of this cosmic giant using the Event Horizon Telescope. It wasn't a photograph in the ordinary sense, but a map of radio waves stitched together from telescopes across the planet. What appeared was a glowing ring of orange light, the shadow of the black hole, surrounded by swirling plasma. It looked peaceful, almost like a cosmic eye staring quietly into the dark. But what it represents is beyond comprehension, a region where the known laws of physics collapse into mystery. Black holes are born from gravity's triumph. When a massive star exhausts its fuel, it collapses inward, its own gravity crushing it to a single point of infinite density. For ordinary black holes, this happens on a stellar scale. For supermassive black holes like Sagittarius A*, their origin is still uncertain. Perhaps they grew from smaller ones, feeding on stars and gas over billions of years. Or perhaps they were born in the early universe, when matter itself first began to gather into galaxies. Around Sagittarius A*, stars orbit at incredible speeds. Some complete a full orbit in just a few years, racing faster than anything else known in the galaxy. One of these, called S2, swings so close that it experiences gravitational redshift, its light stretched by the immense gravity of the black hole. By watching these stars, astronomers can trace the hidden mass at the center, proving Sagittarius A*' existence, even though it cannot be seen directly. The galactic center is far from a quiet place. Dense clouds of gas collide, compress, and give birth to new stars. Powerful radiation bursts from high-energy particles. Massive stars explode as supernovae, feeding more material into the region. In this cosmic storm, Sagittarius A times occasionally stirs, flaring, as it consumes gas or debris. These flares can last for hours, shining briefly brighter than anything else in the galaxy before fading back into stillness. To imagine this place is to imagine extremes. If you were to approach Sagittarius A*, the sky around you would twist and bend, light from stars behind it would curve, wrapping around the black hole's gravity. Time itself would slow near the event horizon, stretching moments into eternity. If you crossed that invisible line, you would never return your matter. Your information, everything you are, would be pulled inward and lost to the singularity. And yet, from a distance, the black hole would remain perfectly calm, its secrets hidden forever. It might seem frightening, a force so powerful that even light cannot escape. But without Sagittarius A*, our galaxy might not exist as it does. Black holes anchor galaxies, helping shape their formation and motion. The stars in the Milky Way's core orbit in harmony because of its gravitational hold. It is the silent conductor of a cosmic orchestra, unseen but essential. Some scientists believe that almost every large galaxy contains a supermassive black hole at its center. The brighter galaxies, known as quasars, have black holes that actively feed, releasing tremendous energy as matter spirals inward. Sagittarius A*, by contrast, is relatively quiet. It consumes little and shines faintly, allowing the Milky Way to live in peace. As you drift through this thought, picture the galaxy from above. The spiral arms glow softly, turning slowly. At the very center, surrounded by glowing dust, lies a small, invisible dot, Sagittarius A*. It does not move. It does not shine, yet everything revolves around it. Its gravity stretches across 100,000 light-years, binding the stars together in a delicate balance. Without it, the galaxy's structure would unravel. The region around Sagittarius A times is not just empty darkness. It is filled with beauty, massive star clusters, colorful nebulae, and strange cosmic phenomena. The central cluster glows with hot young stars. Near it lies the Arches cluster, one of the densest known. Huge filaments of gas thread through space like golden rivers, glowing in radio light. And further out, dense clouds like Sagittarius B2 hold the raw materials for future stars. It is a cosmic furnace where creation and destruction coexist. Astronomers often describe the galactic center as the beating heart of the Milky Way. Like a slow pulse, its energy radiates outward. It influences how gas flows through the galaxy, how stars form, and how light travels. Though hidden, it gives rhythm to the great spiral that we call home. Over billions of years, Sagittarius A times will continue its quiet existence. Sometimes it may awaken, consuming nearby matter and flaring brightly. Other times, it will rest invisible except for the stars that dance around it. One day, far in the future, when the Milky Way and Andromeda merge, their central black holes will also come together, spiraling inward until they merge into an even larger one, a final union that will reshape the heart of the new galaxy. But for now, Sagittarius A times remains still. Its presence can be felt but not seen. Its power immense yet silent. It is the embodiment of cosmic balance, a reminder that even in darkness, there can be order and purpose. As you close your eyes and imagine drifting through the core of the galaxy, picture the glow of countless stars around you. Imagine the dust clouds shimmering with infrared light. Feel the slow, invisible tug of gravity pulling you closer to the center. Everything here moves with quiet purpose, each orbit another note in the grand harmony of the universe. You reach the edge of the event horizon, the boundary of no return. Beyond it, time and space themselves cease to exist as we understand them. But there is no fear, no chaos, only calm. Sagittarius A times rests like a sleeping giant, holding the galaxy together through stillness. And as you drift away, back into the wider arms of the Milky Way, you can still feel its pull, gentle, constant, eternal. The heart of the galaxy beats on, unseen, but ever present. In its gravity lies the story of our home, written not in light but in silence. The silence of Sagittarius A times is not emptiness, it is peace. The deep, timeless peace of a universe that has existed long before us and will continue long after. As you fall asleep under the same sky it commands, remember, you are part of that balance, part of that calm. The same gravity that binds the galaxy binds you too, softly, in the infinite stillness of space. The birth of a galaxy, the beginning of something vast, ancient, and beautiful. Long before the Milky Way, before any stars, before even the faintest glow of light, there was only darkness. A darkness filled not with emptiness, but with invisible potential tiny fluctuations in the fabric of space, ripples that would one day become everything. Galaxies were born from these ripples, nurtured by gravity, shaped by time, and illuminated by the first stars. It all began about 13.5 billion years ago, after the universe's birth, the Big Bang. In its earliest moments, everything was unimaginably hot and dense. Space expanded faster than light, cooling as it stretched. Within the first few 100,000 years, the universe had calmed enough for atoms to form mostly hydrogen and helium. There were no stars yet, no galaxies, only vast clouds of gas drifting through the dark. Slowly, gravity began its quiet work. In some regions, matter was slightly denser than in others. Those tiny differences, mere 1 part in 100,000, became seeds for galaxies. Over millions of years, gas and dark matter began to gather, pulled inward by their own gravity. As they condensed, they formed small clumps called proto-galaxies. These were the embryos of the galaxies we see today. Within these early clouds, gravity continued to compress gas until the first stars were born. They were massive, hot, and bright, far larger than our sun. Their light pierced the darkness, ending the cosmic night. This period, known as the cosmic dawn, marked the beginning of the first galaxies. The radiation from these newborn stars changed the universe forever, reionizing the hydrogen gas that filled space and allowing light to travel freely for the first time. The first galaxies were nothing like the graceful spirals we see today. They were small, chaotic, and irregular, filled with violent energy. Stars formed rapidly, burned quickly, and exploded as supernovae, scattering heavy elements into space. These explosions stirred the surrounding gas, shaping the structure of their galaxies and enriching them with the materials needed to form new generations of stars. Dark matter, an invisible form of matter that doesn't emit light, played a crucial role in this process, though we cannot see it. Dark matter makes up most of a galaxy's mass. It forms giant halos that extend far beyond the visible stars. Without dark matter's gravity, galaxies might never have formed at all. It is the silent framework of the universe, the unseen hand that shaped every cluster and spiral. Over billions of years, these small proto-galaxies began to merge. When they collided, their gas clouds compressed, triggering bursts of star formation. Each merger reshaped the galaxies, sometimes creating larger, more organized systems. Through countless collisions, galaxies grew from tiny, irregular clouds into vast spirals and ellipticals. What was once chaos slowly became order, guided by the laws of gravity and time. Our own Milky Way was born in this way. It began as a collection of smaller galaxies, merging over billions of years. Traces of those early mergers remain today, streams of stars and globular clusters that orbit in the galactic halo, silent witnesses to our galaxy's ancient past. Even now, the Milky Way continues to grow, drawing in dwarf galaxies and absorbing their stars, one by one. Within a forming galaxy, star birth and death go hand in hand. As stars ignite, they produce light, heat, and elements. When they die, they explode, scattering those elements into space. The next generation of stars forms from that enriched gas, creating planets, moons, and eventually the ingredients for life. Every element on Earth, carbon, oxygen, iron, was forged in the heart of a star that lived and died long before our world existed. Galaxies are not just collections of stars. They are cosmic forges, creating the very material of existence. As galaxies matured, their shapes began to stabilize. Some formed into beautiful spirals with long, winding arms. Others became smooth ellipticals, filled with older stars. The exact shape a galaxy takes depends on its history, how fast it spins, how many collisions it has experienced, how much gas remains to form new stars. Even now, galaxies continue to evolve. Some still form new stars in bright nebulae. Others have grown old and quiet, their light fading into the dark. Though galaxies are enormous, their creation is a delicate balance. Too much energy from star formation can blow gas away, halting new growth. Too little, and the galaxy becomes dim and stagnant. Gravity, radiation, and magnetic fields all work together, creating a cosmic equilibrium that keeps galaxies alive for billions of years. From a distance, a young galaxy would look like a storm, swirling clouds of gas and light, flashing with supernovae. If you could watch it form over time, you'd see it settle into a shape, its arms beginning to curl, its stars spreading out like ripples in water. It is a process both violent and graceful, chaotic yet purposeful nature's way of sculpting beauty out of fire and dust. Some of the oldest galaxies discovered so far are seen through the James Webb Space Telescope. Their light has traveled more than 13 billion years to reach us. When we look at them, we are looking back in time to the universe's youth, when the first galaxies were just beginning to shine. These ancient structures are small and red, faint but powerful reminders of how everything began. As the universe aged, galaxies began to gather in groups and clusters, drawn together by dark matter's invisible pull. Over time, these clusters formed even larger structures, superclusters, filaments, and walls weaving a vast cosmic web that stretches across the observable universe. Every node in that web is a galaxy, every strand a bridge of gravity connecting them. In this grand design, no galaxy exists alone. Each one is part of a larger story, connected through time and space. The birth of a galaxy is not an isolated event, but part of the universe's endless rhythm: expansion, formation, evolution, and renewal. Galaxies are born, they grow, they merge, and sometimes they fade, their light slowly dimming as their stars burn out. Yet, from their remains, new galaxies can emerge, continuing the cycle. So as you lie in the quiet of night, imagine watching the universe awaken. Picture vast clouds of gas swirling under gravity's pull, sparks of starlight flickering to life in the dark. Hear the silence of the cosmic dawn, the moment when light first touched the universe. See galaxies forming like glowing islands on a black sea, their shapes changing, merging, and growing over billions of years. Each galaxy that exists today carries the memory of that beginning. The light from their oldest stars still whispers of those first moments. And somewhere in that history, our own galaxy was born, its spiral arms stretching out to cradle a small star we call the sun. The birth of a galaxy is not a single event. It is a story written across time, a slow unfolding of energy and matter. From darkness came light, from chaos came order, and from the silent depths of space came the structures that would one day hold life. You are part of that story. The atoms in your body were born in the stars that formed when the first galaxies began to shine. You carry their light within you, a living echo of the universe's earliest dawn. As you drift to sleep, let that thought rest quietly in your mind, that you are made of the same matter that once floated through the first galaxies, that you are connected to their birth, their stars, and their endless motion. The universe began in darkness, but from that darkness came galaxies, and from those galaxies came you. And the light that shines in the night, it wasn't until the 1,920 seconds when Edwin Hubble used the Hooker telescope at Mount Wilson that humanity discovered galaxies beyond our own. He studied faint patches of light known as nebulae and realized that some were far too large and distant to be part of the Milky Way. Each one was its own island universe, filled with billions of stars. This discovery changed everything. It revealed that the universe was not just vast, but infinite in ways we had never imagined. Today, we know there are more than 2 trillion galaxies in the observable universe. Most of them are so distant that their light has traveled for billions of years to reach us. What we see in our telescopes is not how they are now, but how they were when the universe was young. When you look at a distant galaxy, you are looking into the past, seeing light that began its journey when dinosaurs roamed Earth, or even long before Earth formed. Light travels at nearly 300,000 kilometers per second, yet space is so enormous that it takes millions or billions of years for that light to cross it. The most distant galaxies we've observed are more than 13 billion light years away. That means their light left them when the universe was less than 5% of its current age. Through them, we glimpse the birth and growth of the cosmos itself. The James Webb Space Telescope, launched in 2021, changed our view of these ancient galaxies forever. With its powerful infrared vision, it can see through cosmic dust and capture the faint glow of the universe's earliest structures. It has revealed galaxies that formed just a few 100 million years after the Big Bang, small, bright, and packed with young stars. These galaxies are like fossils, showing us what the cosmos looked like in its childhood. In one of Webb's first deep-field images, a patch of sky no larger than a grain of sand revealed thousands of galaxies. Some were bright spirals and ellipticals, others faint red smudges, the oldest light ever seen. The deeper astronomers looked, the more they found. It was a reminder that every corner of the sky, no matter how empty it seems, holds entire universes of stars and planets. Beyond the galaxies, we can see lies a horizon, the edge of the observable universe. This boundary is not a physical wall, but a limit set by time itself. The universe is about 13.8 billion years old, and light can only travel so far in that time. Because space has been expanding since the Big Bang, the most distant galaxies are now around 46 billion light-years away. Anything beyond that lies outside our reach, forever hidden behind the curtain of cosmic time. Even within the visible universe, many galaxies are invisible to us. Some are shrouded in dust, their light absorbed and re-emitted in wavelengths we cannot detect with ordinary telescopes. Others are faint and distant, their light stretched so much by cosmic expansion that it slips into infrared wavelengths, invisible to human eyes. We know they are there because their gravity leaves subtle imprints on the light from other galaxies, bending it through a phenomenon known as gravitational lensing. Gravitational lensing occurs when a massive object, like a cluster of galaxies, bends and magnifies the light from something behind it. It's nature's own telescope, allowing us to see galaxies that would otherwise be too faint or too far. Sometimes, a single distant galaxy appears multiple times in the same image, distorted into arcs or rings of light. Through this cosmic magnifying glass, we can glimpse galaxies from the universe's earliest ages, fragile structures shimmering at the edge of time. Scientists often talk about the deep-field images from telescopes like Hubble and Webb as time machines. Each pixel in those images contains the light of galaxies billions of years apart in time. In one corner, you might see a young spiral galaxy from a few billion years ago. In another, a tiny red dot glowing from 13 billion years in the past. The universe unfolds before us like layers of history, stacked in light. Beyond the reach of telescopes, there are galaxies we may never see, not because they are too far, but because their light will never reach us. The universe expands faster than light can travel across it. As space stretches, distant galaxies move away from us at increasing speeds. Eventually, their light becomes redshifted beyond detection, fading into darkness. These galaxies still exist, but they have slipped beyond our cosmic horizon. From our perspective, they have vanished, not destroyed, but forever unreachable. This realization brings both awe and melancholy. We live in a universe that we can never fully see, a universe that continues far beyond the limits of our instruments. The galaxies we observe are only a small fraction of all that exists, yet even that fraction contains beauty and complexity beyond comprehension. Every distant galaxy is a story of light traveling across billions of years, of stars being born and dying, of worlds forming and vanishing, of cosmic patterns repeating endlessly in silence. Some of these ancient galaxies are incredibly compact, filled with stars packed so tightly that they shine brighter than anything near us. Others are faint, smudges, the first fragile collections of light in a still-forming cosmos. Their colors tell us their age. Blue for the young, hot stars. Red for the ancient, cool ones. By studying their light, scientists can trace the evolution of galaxies, from chaotic beginnings to the majestic spirals and ellipticals we see nearby. When you look up at the night sky, you might see a few thousand stars, But beyond them lies a field of trillions of galaxies, invisible without the help of technology. They form vast structures, clusters, filaments, and walls separated by enormous voids. If you could see them all at once, the universe would appear like a glowing web, stretching across eternity, pulsing with light. As you close your eyes and drift toward sleep, imagine floating through that web. Picture the faint glow of distant galaxies surrounding you, tiny jewels scattered across infinite blackness. Some of their light began its journey before the sun was born. Some has been traveling since before Earth cooled from molten rock. The light that touches your eyes tonight may have left its home galaxy when the universe was still learning how to shine. Beyond our sight lies an endless expanse of galaxies, each one unique, each one a universe of its own. They whisper through time, sending their light across billions of years to remind us that we are part of something infinite. In the quiet of the night, their light arrives faint, ancient, and patient. It crosses the cold void to reach this small planet, to pass through your atmosphere, to rest on your eyes for just a moment. And in that moment, you are connected to everything, to the galaxies beyond sight, to the stars beyond time, to the infinite expanse of the universe itself. The galaxies we see are only the beginning. Beyond them, beyond even imagination, lies more endless, eternal, unseen. And though their light may never reach us, their existence fills the cosmos with meaning. In the stillness of the night, as you breathe and listen to the quiet, know that even in the darkness, the universe is alive, shining softly, endlessly, just beyond our sight. The Andromeda Galaxy, our closest neighbor in the vast dark sea of space. It hangs like a faint, silvery cloud in the constellation of Andromeda, invisible to city skies but clear under dark ones. What you see as a soft patch of light is actually a massive spiral galaxy, home to nearly 1 trillion stars. It is the Milky Way's twin in many ways, but also its future four. In 4 billion years, the two galaxies will collide, merging into one giant cosmic structure. Yet tonight, Andromeda drifts quietly, gliding through space, 2.5 million light-years away. Imagine that distance. Light, moving at 300,000 kilometers per second, takes 5 million years to travel from Andromeda to your eyes. That means the light you see tonight left the galaxy long before humans existed, before the first cities, before civilization, before our ancestors even learned to use fire. It has traveled across time and emptiness, crossing the dark void to arrive softly in the lens of your eyes. What you see is Andromeda's ancient self, a glimpse into the distant past. Andromeda is the largest galaxy in the local group, the small cluster that includes our Milky Way, the Triangulum Galaxy, and about 50 dwarf galaxies. It stretches more than 220,000 light-years across, nearly twice the diameter of the Milky Way. Through telescopes, it reveals delicate spiral arms and a bright central core, glowing softly with the combined light of billions of suns. Astronomers call it M31, the 31st object in Charles Messier's catalog of celestial wonders. But long before telescopes, ancient observers noticed it as a mysterious, nebulous cloud in the sky. In 964 AD, the Persian astronomer Abd al-Rahman al-Sufi recorded it in his book of fixed stars, calling it a small cloud. For centuries, no one knew what it really was until Edwin Hubble, in the 1922nd, discovered that Andromeda was not part of our galaxy at all, but an entirely separate universe of stars. That realization expanded our understanding of the cosmos forever. Andromeda is a spiral galaxy like our own, with long, curved arms swirling outward from its glowing core. Those arms are filled with dust, gas, and regions of star formation, pink and blue nebulae where new stars are born. The galaxy's core shines with older, yellowish stars packed tightly together. And deep within that core lies a supermassive black hole, tens of millions of times the mass of our Sun. When we look at Andromeda, we are seeing both past and future. It is drifting slowly toward us at about 400,000 kilometers per hour, a cosmic inevitability written by gravity. Though it may sound fast, the space between us is so vast that the collision won't happen for another 4 billion years. When it does, it will not be a crash, but a dance. Two spirals twisting together, their stars swirling, merging, and settling into a new, larger form. Astronomers have simulated this event. First, the galaxies approach, their outer arms stretching and distorting under tidal forces. They pass through each other, their stars mostly avoiding direct collisions because of the immense distances between them. But their gravity stirs up waves of gas, triggering bursts of star formation that light up the galaxies in a blaze of new life. After several passes and billions of years, the Milky Way and Andromeda will merge into a single giant elliptical galaxy, perhaps called Milkomeda, glowing softly in the fading light of a mature universe. For now, though, Andromeda drifts peacefully. It dominates its corner of the cosmos, surrounded by smaller companions, dwarf galaxies like M32 and M110, which orbit it just as our moon orbits Earth. These dwarfs are faint and fragile, often pulled apart by Andromeda's gravity. Their stars leave trails across space, silent evidence of the slow power of galactic forces. If you could travel to Andromeda and stand on a planet orbiting one of its stars, the night sky there would be breathtaking. The Milky Way would appear as a bright spiral in the distance, stretching across the heavens, a glowing bridge between galaxies. Perhaps from there, someone or something could look back and see us as a tiny blur of light, wondering what stories our galaxy holds. Andromeda is not just a beautiful spiral, it's a living laboratory. By studying it, astronomers learn about the structure, evolution, and fate of galaxies. Because it's so close, we can observe it in incredible detail. Its dust lanes, star clusters, and even individual stars in its outskirts. Each observation helps us understand how galaxies grow, how stars form, and how the universe changes over time. Beyond its science, Andromeda carries something poetic, a sense of connection. It reminds us that we are not isolated in space. Our galaxy and Andromeda are bound together by gravity, slowly moving toward each other like two old companions destined to meet. In that meeting, there is no destruction, only transformation. Their stars will merge, their orbits will change, and new worlds may be born. In the dark quiet of night, when you look toward the constellation of Andromeda, remember that you are seeing not just light, but history. Each photon, striking your eyes, began its journey long before humanity, carrying with it the memory of another world. It crossed the void for millions of years, untouched by anything, until now. In that moment, the distance between galaxies disappears, and you are connected to something infinite. One day, when Andromeda finally reaches us, the sky will transform. Over millions of years, it will grow larger and brighter until it fills the heavens with light. The night sky will no longer be dark, but alive stars stretched across every direction. And when the galaxies merge, the sun and its planets may drift into a new orbit, far from where they began. The Earth may no longer exist, but the atoms that once formed it will continue their journey in the new galaxy, part of a greater whole. So as you fall asleep, imagine Andromeda above you, a distant spiral glowing softly through the void. Imagine its countless stars, each one with its own story. Imagine its slow approach, patient and timeless. The silence between galaxies is not emptiness, it is waiting, a waiting so long and peaceful that even light takes millions of years to cross it. Andromeda's light falls on us tonight, ancient and unchanged. It is a reminder that we live in a connected universe, that our galaxy is part of something larger, that our sky is shared with countless others. Every photon that reaches your eyes is a message from deep time, saying, "You are not alone in this endless expanse." Breathe softly. Let the thought of that distant spiral calm your mind. Picture its glow, its arms spinning slowly in the dark, its light flowing gently across the black sea of space. One day, long after we are gone, the Milky Way and Andromeda will embrace, their lights blending, their stars dancing as one. And even then, the universe will continue, vast and serene, filled with galaxies drifting forever in the quiet rhythm of time. The future of our galaxy, a story written in light, gravity, and time. Though the Milky Way feels timeless, it too has a destiny. Nothing in the universe stands still forever. Galaxies live, grow, and evolve. They collide, merge, fade, and change form. Our home, this elegant spiral of stars, is still in the middle of its cosmic life. But billions of years from now, it will look very different. Tonight, as it glides silently through space, it is already on its way to meet its fate. A grand union with the Andromeda Galaxy. The Milky Way and Andromeda are not drifting apart like most galaxies. Instead, they are bound together by gravity, slowly pulling toward each other at a speed of nearly 400,000 kilometers per hour. This collision will not happen soon. It lies about 4 billion years in the future, but it is certain. It's a slow, graceful dance, written in the physics of motion and the quiet pull of mass. If you could speed up time and watch the sky change over billions of years, you'd see Andromeda grow brighter. It would no longer appear as a faint smudge, but as a glowing disk, expanding each million years. Eventually, it would dominate the night sky, a luminous spiral stretching across the heavens. Stars from both galaxies would begin to interact gravitationally, their paths bending and twisting. The shapes of the galaxies would distort, their spiral arms stretched into long, delicate streams of light. Yet, despite the name collision, very few stars will actually hit each other. The space between stars is so vast that they will mostly pass by unharmed. What will change is their orbits. The gravitational tides of this encounter will rearrange the stars, tossing some into the outer reaches of space and pulling others toward the center. Entire solar systems, perhaps including ours, will drift to new locations within the merged galaxy. Astronomers have simulated this event in great detail. First, the galaxies will pass through each other, their shapes twisted and their centers pulled apart. Then they will swing around and collide again, merging more deeply. After several passes, they will settle into a single, massive elliptical galaxy, smooth, bright, and round. This new structure, sometimes called Milkomeda, will become our future home. It will shine with the combined light of both galaxies, but its star formation will eventually slow as gas runs out. Over time, it will grow older, redder, and quieter. The supermassive black holes at the centers of both galaxies, Sagittarius A times in the Milky Way and the even larger one in Andromeda, will also move toward each other. They will orbit for millions of years, drawing closer as they lose energy through gravitational waves. Finally, they will merge into one colossal black hole, billions of times the mass of the Sun. This event will release an enormous burst of gravitational energy, rippling across the fabric of space-time. Yet even this, in the grand timeline of the cosmos, will pass in silence. While this future may sound distant and dramatic, it will unfold slowly, almost peacefully. Each phase will take millions of years. No single being will witness the entire event, yet the story will continue whether anyone is watching or not. Planets will continue to orbit stars. New stars will be born in the clouds of colliding gas. Old stars will die and scatter their elements to form new worlds. Even in this vast transformation, life and light will persist. When the collision begins, our night sky will be breathtaking. From Earth, if it still exists, you would see Andromeda stretch across the horizon. Its spiral arms would glow softly, filling the sky with a tapestry of stars. As the galaxies merge, the view would grow brighter, filled with streaks of light as stars pass close to one another. It would be a cosmic dawn, a night so beautiful that it would seem unreal, a living painting of the universe's quiet power. But by then, the sun will have changed too. In about 5 billion years, it will swell into a red giant, its outer layers expanding to consume Mercury and Venus. The Earth's oceans will evaporate, its surface will burn, and life as we know it will end. If any remnants of humanity survive, perhaps living on other worlds, they might watch the galactic collision from afar, witnessing the creation of a new cosmic home. In the far future, when Milkomeda has settled into its new form, it will stand alone. The expansion of the universe is accelerating, driven by dark energy. As time passes, other galaxies will drift farther and farther away, their light redshifted until it disappears completely. Trillions of years from now, Milkomeda may be the only visible galaxy left in the sky. The rest of the universe will fade into darkness, leaving this single island of stars surrounded by endless night. Inside it, stars will continue to live and die. The brightest will burn out quickly. The smallest will fade slowly, cooling into white dwarfs and eventually into coal black remnants. The galaxy will dim as its light sources vanish one by one. Even black holes will evaporate over unimaginable spans of time, releasing their last traces of energy into the void. The universe, once filled with light and motion, will fall silent. Yet this future is not sad. It is simply the rhythm of existence. Everything that begins must evolve. The galaxies we see today are the result of countless earlier mergers. The Milky Way itself was born from collisions billions of years ago. The merging with Andromeda is just another step in that eternal cycle. Destruction and creation are the same in the cosmos. One gives rise to the other. Tonight, as you look up at the stars, the sky seems still. The Milky Way arches quietly above, its light soft and ancient. But beneath that calm, galaxies are moving, slowly drifting, preparing for their distant meeting. The future is already in motion, written in the silent pull of gravity. Imagine yourself floating between the two galaxies, watching their approach. At first, they seem distant, faint swirls of light. But as eons pass, they grow larger, their arms reaching toward each other. The space between them glows with newborn stars. Eventually, they merge, forming one vast structure, a single heartbeat in the endless life of the universe. The future of our galaxy is not something to fear, but to marvel at. It reminds us that even the most immense things change. It tells us that beauty can emerge from chaos, and that endings are just beginnings written on a larger scale. So as you fall asleep, imagine the soft glow of the Milky Way blending with the light of Andromeda. Picture the slow, silent merging of stars, the gentle curve of galaxies becoming one. In the far distance, everything fades into the calm of eternity, and within that calm, you drift peacefully, a part of the same vast story, carried by the same cosmic tide that shapes galaxies and dreams alike. The colors of galaxies, a cosmic palette painted with light, age, and time. When you look up at the night sky, it might seem as though all stars shine the same white or yellow, faint or bright. But when seen through the eyes of powerful telescopes, galaxies reveal a breathtaking spectrum of colors: soft blues, glowing pinks, golden yellows, deep reds. Each shade carries meaning. Each color tells a story about the life, death, and age of the stars within. Galaxies are not merely distant structures. They are living artworks, their hues the language of the universe. To understand the color of a galaxy, we must first understand that light is time. Every color we see is a message from the past, shaped by the stars that produced it. Young, hot stars burn blue, their energy fierce, their lifespan short. They illuminate regions where new stars are being born, filling spiral arms with a shimmering, icy light. In contrast, older stars glow red or yellow, their heat fading with age, their light softer and more golden. Together, these stars form the gradients we see across galaxies, a quiet symphony of light and color that tells the story of their evolution. Spiral galaxies like our Milky Way often shine in blue and white. Their arms are active, filled with nebulae and clusters where new stars are forming. The center, by contrast, glows yellow, a dense hub of older stars that have burned for billions of years. This mix of blue spirals and golden cores gives them their familiar, graceful appearance. The brighter and bluer a spiral galaxy appears, the more actively it is forming stars. Elliptical galaxies, however, tell a different story. They are smooth, featureless, and golden red in tone. They have used up most of their gas and dust, leaving little material for new stars to form. Their stars are ancient, slowly cooling over time. An elliptical galaxy's soft amber glow is like the fading warmth of a dying fire, beautiful, calm, and timeless. Then there are irregular galaxies, wild, chaotic, and often vividly colored. Many are rich in gas and dust, their star-forming regions glowing pink and purple under the light of hydrogen emission. These irregulars, shaped by gravitational encounters or collisions, are filled with life and motion. Their colors shift from deep blues to radiant reds, a living reminder of the universe's creative chaos. The colors we see are not just aesthetic, they are scientific fingerprints. Astronomers use them to measure a galaxy's age, temperature, and composition. By splitting a galaxy's light into its spectrum, they can identify the chemical elements it contains: hydrogen, helium, oxygen, iron, and more. Each element absorbs and emits light at specific wavelengths, leaving behind a distinct pattern. Through these patterns, scientists can read the story of galaxies as clearly as one might read words on a page. Galactic colors are also shaped by dust, the fine particles of carbon and silicon that drift between stars. Dust scatters blue light and lets red light pass through, much like a sunset on Earth. That's why some galaxies appear redder than they truly are. Their light has traveled through clouds of dust, softened and reddened along the way. This effect, called reddening, gives galaxies a warm, ancient look, even when young stars still burn within. Another phenomenon, redshift, changes color on a universal scale. As the universe expands, light from distant galaxies stretches, its wavelength lengthening as it travels through space. What began as blue or white light arrives to us as red or infrared. The farther away a galaxy is, the more its light is redshifted. This cosmic stretching allows astronomers to measure distance. The color of a galaxy, quite literally, tells us how far back in time we are seeing. Some galaxies shine in invisible colors, ultraviolet and infrared, beyond what human eyes can see. Ultraviolet light reveals the youngest, hottest stars, blazing with fierce energy. Infrared light, on the other hand, shows the cooler, dust-shrouded regions where stars are forming in secret. Telescopes like Hubble and James Webb combine these wavelengths to paint the full picture, revealing the hidden layers of galactic light. The pinkish glow, often seen in photographs of galaxies, comes from hydrogen alpha emission, the soft red light released when electrons in hydrogen atoms fall from one energy level to another. It marks the places where stars are born, vast nurseries stretching across light years. In spiral arms, these glowing patches form chains and swirls, tracing the structure of the galaxy like luminous veins. Blue light, sharp and cold, comes from massive young stars, the giants that live fast and die young. They burn intensely for only a few million years before exploding as supernovae, spreading heavy elements into the interstellar medium. When these blue regions fade, they leave behind the seeds for new generations of stars. In contrast, the golden light of older stars dominates galactic cores and elliptical galaxies. It is steady and gentle, the light of suns that have burned quietly for billions of years. These stars no longer form new life, but their glow sustains the galaxy's beauty, a reminder of endurance in a universe of change. Sometimes, colors blend in unexpected ways. Colliding galaxies can ignite bursts of star formation, creating brilliant patches of blue among golden backgrounds. In others, dust lanes cast deep shadows across glowing spirals, creating contrasts of light and darkness. These variations are the fingerprints of galactic history, each one unique, shaped by time, gravity, and chance. Beyond the scientific meaning, the colors of galaxies hold a poetic truth. They reflect the passage of cosmic time: blue for youth, gold for maturity, red for age. Galaxies evolve much like living things, their light aging as their stars live and die. To look at a galaxy's color is to glimpse its lifetime condensed into a single image, a frozen moment in an unending story. If you could float through space and watch galaxies up close, the view would be mesmerizing. You'd see brilliant blue clusters blazing within the spiral arms, glowing red clouds marking star birth, and soft amber centers radiating warmth. The darkness between would shimmer faintly with dust and gas, a gentle reminder that even the void is alive with light. As you close your eyes tonight, imagine drifting among them, a traveler through the colors of the cosmos. You pass a spiral galaxy, glowing blue and silver, its arms curling like waves of starlight. Then you drift toward a quiet elliptical, its light golden and still. Further out, faint red smudges mark galaxies at the edge of time, their colors stretched by the expansion of the universe. In the silence of that vastness, the colors blend: blue, fading to white, white to gold, gold to red, and red into darkness, the palette of creation, fading softly into the endless night. These colors are more than light. They are the echoes of everything that ever was. They tell of the first stars, the rise of galaxies, and the slow aging of the universe itself. And within that spectrum, you exist, a being of stardust and color, born from the same light that shines in those distant galaxies. So as you rest, imagine yourself surrounded by that cosmic glow: blue for beginnings, gold for endurance, red for memory. The colors of galaxies wash gently over you, whispering the quiet truth of the universe that everything changes, yet everything remains light, drifting endlessly through the infinite night. The shapes of the universe, the architecture of infinity, carved by gravity and time. Every galaxy, every cluster, every glowing island of stars carries a distinct form. Some swirl like whirlpools of light, their arms spiraling outward in perfect rhythm. Others are smooth and rounded, ancient and quiet. Some appear irregular, chaotic, and wild, defying symmetry altogether. The shapes of galaxies are not random. They are written by their histories, by collisions, by motion, by the slow pull of unseen matter. To understand their forms is to read the handwriting of the universe itself. When astronomers first began to classify galaxies, they were astonished by the variety of shapes scattered across the sky. In the 1922nd, Edwin Hubble created a system still used today, the Hubble sequence, often called the cosmic tuning fork. It arranged galaxies into families: spirals, ellipticals, and irregulars. Though simple, this classification revealed a truth about the universe, that beauty in the cosmos follows form, and form follows history. Spiral galaxies, like our Milky Way and Andromeda, are perhaps the most graceful. They are flat, disc-like structures with swirling arms winding outward from a central bulge. Their shapes are defined by rotation, the slow spinning motion that organizes gas, dust, and stars into spiral patterns. These arms are not solid structures, but waves of density, like ripples in water. As matter moves through these waves, stars form, shine, and drift away. This creates the illusion of curved, glowing arms, a dance of motion and light that can last billions of years. The center of a spiral galaxy glows brightly, filled with older stars that have orbited for eons. Around it, the disk is home to younger, bluish stars and vast nebulae. Dust lanes trace the arms, dark and shadowy, absorbing light and adding texture to the spiral's brilliance. In edge-on view, a spiral galaxy looks like a thin streak of light, a shining blade cutting through the darkness, glowing softly at its edges. Some spirals have strong bars of stars cutting through their centers. These are called barred spirals. The bar acts like a bridge, channeling gas toward the core and fueling star formation near the center. Our Milky Way is one of them, its bar hidden behind dust, but visible in infrared light. Such bars are temporary, lasting only a few billion years before dissolving, showing how galaxies constantly reshape themselves. Elliptical galaxies are very different. They are smooth, oval-shaped collections of stars with little or no structure. They contain almost no gas or dust, meaning new stars rarely form. Their light is warm and golden, coming from ancient suns that have burned for billions of years. Some ellipticals are small, like cosmic pearls. Others are enormous giants, like IC 1101, which stretches 6 million light-years across and contains hundreds of trillions of stars. These galaxies are the silent cities of the cosmos, vast and old, where star formation has long ceased. How do galaxies lose their spirals and become ellipticals? The answer lies in collisions. When two spirals collide, their ordered rotation is disrupted. Their gas is stirred, compressed, and eventually consumed in bursts of star formation. What remains settles into a more rounded shape, a smooth blend of stars orbiting in random directions. Over time, the gas runs out, and the galaxy grows quiet, fading into an elliptical form. And then there are irregular galaxies, the wild ones. They lack symmetry, their shapes twisted by gravity or by encounters with larger neighbors. Many are small, full of gas and new stars. Some were once spirals, distorted by collisions. Others are still forming, fragments of cosmic material coming together for the first time. In these irregulars, the universe reveals its chaotic side, unrefined, unpredictable, alive with motion. Beyond these main types are galaxies with rarer, exotic shapes. Ring galaxies, for instance, have bright circular structures, rings of stars formed by head-on collisions. One famous example, the Cartwheel galaxy, looks like a cosmic eye staring out into the void. Lenticular galaxies, meanwhile, are hybrids, disks, like spirals, but without visible arms. They represent a transitional phase, where a galaxy's gas has been stripped away, leaving only stars in a quiet, disk-like form. There are even galaxies that defy classification entirely, warped, bent, or stretched by gravitational interactions. Tidal forces from nearby galaxies can pull them into streams of stars, creating bridges and tails that extend across millions of light-years. Each one is a story frozen in shape, the visible aftermath of cosmic encounters written across the sky. But even these individual forms fit into a larger design. Galaxies themselves gather into groups, clusters, and filaments that form the grand structure of the universe. If you could step back far enough billions of light years away and look at everything at once, the universe would appear like a vast, glowing web. Galaxies form nodes at the intersections of filaments, while empty voids stretch between them. The shapes of galaxies, multiplied across trillions, create the texture of reality, a cosmic pattern that mirrors the networks of life itself. What's most beautiful is how the shape of a galaxy can tell its story without words. A smooth elliptical whispers of ancient time, of calm after violence. A blue spiral speaks of youth, energy, and birth. An irregular galaxy screams of collisions and chaos. Each form is a photograph of its life, frozen in the moment we see it, yet still changing beyond our sight. And the shapes we see are also illusions of time. Because light takes so long to reach us, the galaxies in our telescopes are not as they are now, but as they were millions or billions of years ago. Some may have merged, faded, or vanished entirely since their light began its journey. Every shape we see is both real and a ghost, a memory of a moment that no longer exists. As you drift into the quiet of night, imagine floating among these shapes. You pass a spiral galaxy, its arms glowing blue, swirling like a slow ocean wave. You drift toward an elliptical, its golden haze, calm and steady, ancient beyond measure. Then you glide by an irregular, its light scattered, vibrant, untamed. Each one different, each one alive in its own way. The silence of space is not empty, it is sculpted. The universe, in all its vastness, has shape and symmetry, rhythm and form. The galaxies are its brushstrokes, its spirals and curves drawn across the infinite canvas of night. And you, floating here in thought, are part of that same geometry. Your atoms were once arranged in the heart of a star, inside a spiral arm that long ago burned away. The patterns that shape galaxies also shape you. Gravity, motion, time. As you close your eyes, imagine the curves of the cosmos spinning slowly in the dark, their light soft and eternal. The shapes of the universe are not only out there, they are within you too. Everything that exists, from galaxies to dreams, follows the same design. Born from chaos, shaped by time, and destined to become something beautiful in the silence of eternity. Dwarf galaxies, the quiet wanderers of the cosmos, small yet mighty. While great spirals and vast ellipticals often steal our attention, most galaxies in the universe are not grand or luminous. They are tiny, dim, and ancient. The dwarfs, they drift silently through the dark, holding only a few million or a few billion stars compared to the hundreds of billions in galaxies like our Milky Way. Yet these small, faint structures are the hidden architects of the universe, the building blocks from which the great galactic giants were born. The story of dwarf galaxies begins in the early universe, when matter first started to clump together under the pull of gravity. Before large galaxies existed, there were countless small ones, tiny clouds of gas and dark matter, where the first stars began to shine. Over time, these small galaxies merged, colliding and combining to form larger systems. Every massive galaxy we see today is built upon the remains of countless dwarfs, long ago devoured or absorbed into something greater. But not all dwarfs were consumed. Many still survive, scattered like ancient relics across the cosmic web. They orbit larger galaxies, drift alone in the vast intergalactic void, or cling together in small clusters. Though faint and fragile, they tell the oldest stories of the universe, tales of its formation, growth, and endurance. Our own Milky Way is surrounded by a family of dwarf galaxies. They move around it like quiet companions, each with its own shape and history. Among the most famous are the large and small Magellanic Clouds, visible from the southern hemisphere as faint, glowing patches in the night sky. They are irregular dwarfs, filled with gas and bright regions of star formation. They orbit the Milky Way in a slow dance, leaving trails of gas behind them, vast ribbons stretching across the sky, known as the Magellanic Stream. These Magellanic Clouds are among the few dwarf galaxies visible to the naked eye, but dozens more surround us, hidden in the dark. Many are so faint that they were only discovered recently, through deep sky surveys and long exposures. Some, like the Sagittarius dwarf spheroidal galaxy, are being torn apart by the Milky Way's gravity. Its stars stretch into long curved streams that wrap around our galaxy, a cosmic scar left by its disintegration. Others, like the Draco and Sculptor dwarfs, are small and ancient, containing stars that are nearly as old as the universe itself. Dwarf galaxies come in many forms. Some are irregular, their shapes scattered and chaotic, often disturbed by nearby giants. Others are spherical, compact clusters of old stars, dim but stable. Some are ultra-faint dwarfs, barely detectable, with so few stars that they seem like whispers of light lost in the void. Then there are blue compact dwarfs, tiny galaxies bursting with new star formation, glowing brightly despite their size. Each one represents a stage in galactic evolution, a snapshot of how matter gathers, changes, and survives. Though they are small, dwarf galaxies play a vital role in the cosmic ecosystem. They are rich in dark matter, the invisible material that makes up most of a galaxy's mass. By studying how stars move within these dwarfs, astronomers can learn about dark matter's mysterious properties. Dwarfs are also laboratories for understanding how stars form in extreme environments, where gas is scarce and gravity weak. In their simplicity, they reveal truths that larger galaxies conceal. Collisions between dwarfs and larger galaxies are common. As they approach, gravity tears them apart, scattering their stars into the larger system. In this way, dwarfs act as fuel for galactic growth, their gas and stars feeding the creation of new structures. Our Milky Way has absorbed many dwarfs throughout its history, and evidence of these mergers can be found in the halo of stars surrounding it. The streams and clusters in that halo are remnants of ancient dwarf galaxies, their light still moving through our sky. But not all dwarfs fall victim to giants. Some live independently, floating alone in the cosmic void, untouched for billions of years. These isolated dwarfs are among the most primitive objects in the universe, preserving the conditions of the early cosmos. Their stars are old and metal-poor, meaning they formed when the universe was still young, before heavier elements existed. Looking at them is like peering into a time capsule, seeing the universe as it was soon after it began. In the local group, the small neighborhood of galaxies that includes the Milky Way and Andromeda, there are more than 70 known dwarf galaxies. Some are satellites of the major spirals. Others wander freely. Together, they form a complex web of motion and gravity, a miniature version of the cosmic structure that fills the larger universe. In clusters beyond, the number of dwarfs rises into the thousands, swarming around giant ellipticals like stars around a sun. Though faint, dwarf galaxies can sometimes shine with sudden brilliance. When two dwarfs collide, the impact can compress their gas and ignite bursts of star formation, lighting them up like cosmic embers. These events are rare and short-lived, but they remind us that even the smallest galaxies can give rise to beauty and energy beyond their size. Over cosmic time, many dwarfs will vanish, absorbed by larger systems or dissolved into the background, but their legacy will endure, written in the stars they contributed to greater galaxies. Every massive spiral, every glowing core, carries within it the light of ancient dwarfs that once drifted freely. If you could see the universe from afar, not just the bright galaxies, but everything, you'd find that most of its structure is made of dwarfs. They are the scaffolding upon which the cosmos was built, the hidden bones of creation. Though they shine softly, they are countless, filling the night with invisible threads of light. As you close your eyes, imagine drifting among them, small clusters of stars, glowing faintly in the dark, quiet and eternal. No grand spirals, no bright cores, only gentle light scattered across infinity. Each dwarf galaxy a lantern in the void, its glow ancient and steady. The Magellanic Clouds drift nearby, their wisps of gas painting the sky. Far beyond them, other dwarfs orbit unseen, tracing the invisible gravity of the Milky Way. They move slowly, gracefully, bound to a dance billions of years long. In their quiet, they remind us that greatness does not depend on size or brightness. Even the smallest galaxies hold entire histories within them. Stars, planets, perhaps even life. They are the whispers of the cosmos, soft and enduring, telling the same story as the giants, but in gentler tones. So as you fall asleep, picture those tiny galaxies gliding through the dark. They may be small, but their light has crossed billions of years to exist here now. You are surrounded by them, countless little worlds scattered across eternity, each one a heartbeat in the quiet rhythm of the universe. Star factories, the glowing hearts of galaxies where new suns are born. Scattered across the universe, these vast, colorful clouds of gas and dust pulse softly with energy, creating the stars that light up galaxies and give birth to planets, life, and warmth. They are called nebulae, stellar nurseries, the true engines of stars. They are living structures, constantly creating and renewing themselves. In spiral arms, glowing regions mark the places where star formation is strongest, clusters of nebulae that burn in pink and blue hues. Each nebula holds the potential for hundreds, thousands, even millions of stars. Over millions of years, they collapse, ignite, and fill the galaxy with light. A nebula begins as a cold cloud of hydrogen and helium, stretching across light years. For ages, it drifts quietly, disturbed only by faint waves of gravity or the passing of nearby stars. But then something happens, a shock wave from a supernova, or the slow pull of gravity itself, and the cloud begins to collapse. Denser regions form within it, clumps that grow heavier as more material falls inward. As they compress, heat builds at their centers, and soon, the first signs of life appear, the birth of new stars. These newborn stars ignite when the pressure and temperature in their cores become high enough for nuclear fusion. Hydrogen atoms fuse into helium, releasing light and energy. That light pushes away the surrounding gas, shaping the nebula into fantastic patterns, pillars, waves, and arcs, glowing softly in the cosmic night. One of the most famous examples is the Orion Nebula, visible to the naked eye just below Orion's belt. It is one of the closest star factories to Earth, only about 1,300 light-years away, and within it, thousands of stars are being born at this very moment. The Orion Nebula is vast, more than 20 light-years across, and filled with young, hot stars, whose ultraviolet radiation lights up the surrounding gas. Its colors, captured by telescopes, reveal the presence of different elements: hydrogen glowing red, oxygen shining green, and sulfur casting a faint blue. Together, they create one of the most breathtaking sights in the universe, a living cloud of creation. In galaxies beyond our own, similar regions can be found everywhere. The Carina Nebula, the Lagoon Nebula, the Trifid Nebula, all are stellar nurseries, each with its own beauty. In the large Magellanic Cloud, there is the Tarantula Nebula, one of the most active star-forming regions in our cosmic neighborhood. It glows with such intensity that if it were as close as the Orion Nebula, it would cast visible light across our night sky. Within its heart lies a cluster of massive newborn stars, their winds carving vast cavities through the gas, sculpting the nebula into strange and delicate shapes. Star formation is both delicate and powerful. Gravity pulls the gas inward, but radiation from newborn stars pushes it outward. The balance between these forces determines how many stars a nebula will create. If the pressure is too high, the gas disperses, and the process stops. If gravity dominates, the cloud collapses too quickly, forming massive stars that live fast and die young. Each nebula has its rhythm, a slow breathing of creation and destruction that shapes its form and its destiny. Over time, the nebula's gas is consumed or blown away, leaving behind clusters of young stars. These clusters drift apart slowly, their stars spreading through the galaxy. Some will become part of spiral arms. Others will wander into the galactic halo. Among them, some stars will host planets, and perhaps on a few of those planets, life will emerge, a continuation of the nebula's work in another form. But not all nebulae create stars. Some are remnants, the ashes of old suns. When massive stars die, they explode as supernovae, blasting their outer layers into space. What remains is a supernova remnant, a glowing shell of gas expanding through the void. The Crab Nebula is one such remnant, the aftermath of a star that exploded nearly 1,000 years ago. At its center lies a neutron star, the collapsed core, spinning rapidly, sending pulses of radiation across the cosmos. Other nebulae form when smaller stars reach the end of their lives. As they run out of fuel, they shed their outer layers, creating what are called planetary nebulae, delicate round shells of gas surrounding a dying star. These nebulae glow with haunting beauty, their light a final gift from a sun that once shone brightly. Over time, they fade, leaving behind a white dwarf, a tiny, dense remnant of the star that once was. In this endless cycle, nebulae are both the beginning and the end. The gas expelled by dying stars becomes the raw material for new ones. Nothing is wasted. Every atom is recycled, every molecule reborn. Galaxies breathe through these nebulae, their light pulsing with the rhythm of creation. In the heart of the Milky Way, star factories are especially active. Dense clouds in regions like Sagittarius B2 and the Eagle Nebula produce stars in great numbers. In the Eagle Nebula lies the famous Pillars of Creation, towering columns of gas and dust captured by the Hubble telescope. Within these pillars, stars are forming even now, their light slowly eating away the structures that gave them life. The image is both peaceful and powerful, a reminder that creation often destroys and destruction often creates. Every star you see in the night sky once emerged from such a place. Our own sun was born from a nebula about 4.6 billion years ago. When it formed, it was surrounded by a disk of gas and dust that eventually became the planets, including Earth. That same nebula gave us the carbon in our bodies, the oxygen we breathe, the iron in our blood. We are, in a very real sense, children of nebulae, fragments of ancient star factories, still glowing faintly within us. As you drift to sleep, imagine floating through one of these stellar nurseries. Great clouds stretch around you, glowing softly in pink and violet light. In the distance, young stars shimmer, their light scattering through the gas. You watch as new stars ignite, one after another, tiny flames in an infinite darkness. Time feels different here. Millions of years pass, like seconds, and yet everything moves with calm purpose. The airless silence is filled with quiet creation, the hum of light being born. The nebula breathes, expanding and contracting, alive in a way that transcends thought. As you drift deeper into the calm, remember this: the light from your sun, the atoms in your body, the warmth that fills your heart, all began in a place like this. You are made of the universe's oldest art, crafted in the same star factories that shape the galaxies themselves. The galaxies may seem far away, but their light is within you. And as you sleep, the stars continue to form, the nebulae continue to glow, and the universe continues its endless creation, soft, eternal, and beautifully silent. Black holes and galactic power, the dark hearts of galaxies, silent yet dominant. They do not shine, they do not speak, but their gravity shapes everything around them. In the center of nearly every large galaxy, a supermassive black hole waits vast, invisible, patient. It consumes matter, bends light, and governs the motion of billions of stars. Without them, galaxies might not hold together. They are both destroyers and creators, the unseen engines that drive the universe. Black holes are born from collapse, the final act of a massive star's life. When a giant star runs out of fuel, its core implodes under its own weight, compressing into a point of infinite density called a singularity. The gravity becomes so strong that nothing, not even light, can escape. What remains is a region of space defined not by matter, but by absence, the event horizon, the boundary beyond which no information can return to the outside world. It is as if the star has vanished, leaving only a shadow in the fabric of space-time. But supermassive black holes are different. They are not a few times the mass of the sun. They are millions or billions of times more massive. How they form remains one of the universe's great mysteries. Perhaps they began as smaller black holes in the early cosmos, feeding and merging over billions of years. Perhaps they formed directly from colossal gas clouds collapsing under their own gravity before the first stars were born. Whatever their origin, they became the anchors of galaxies, the gravitational hearts around which stars gathered and disks of light spun. In the core of our Milky Way lies such a black hole, Sagittarius A*. It holds about 4 million solar masses within a region smaller than our solar system. Stars near it move at incredible speeds, slingshotting around the invisible center. Though we cannot see it directly, its presence is unmistakable, revealed by the motion of the stars it commands. In 2022, the Event Horizon Telescope captured an image of its shadow, a glowing ring of light bent by gravity, a doorway into darkness itself. When matter falls toward a black hole, it forms an accretion disk, a swirling, luminous whirlpool of gas and dust, heated to millions of degrees. As the material spirals inward, it accelerates and glows with incredible brightness, emitting X-rays and gamma rays. Sometimes, magnetic fields near the black hole focus this energy into narrow jets of plasma that shoot out at nearly the speed of light, extending across thousands of light years. These are the galaxy's lighthouses, quasars, and blazars, among the most powerful sources of energy in existence. A quasar is what happens when a black hole feeds furiously. Matter funnels into its core, releasing energy as bright as trillions of suns. From across billions of light years, we can see quasars shining so bright they outshine entire galaxies. Some of the earliest objects we've observed in the universe are quasars, their light beginning its journey when the cosmos was young. They reveal that even in the earliest times, supermassive black holes were already shaping the flow of cosmic energy. When a black hole is active, its influence reaches far beyond its immediate surroundings. The radiation and winds it produces can heat and blow away gas throughout the galaxy, slowing the formation of new stars. This process, known as feedback, regulates a galaxy's growth, keeping it from becoming too large or too dense. In this way, black holes act as cosmic thermostats, maintaining balance in their galactic homes. In elliptical galaxies, which are often old and quiet, their central black holes have long since finished feeding. They rest in silence, having consumed most of the nearby gas. In spirals like ours, the black hole occasionally wakes, flaring as it consumes bits of matter that drift too close. In distant galaxies, some black holes remain fiercely active, their energy shaping not just their host galaxies but entire clusters around them. The largest known black holes are truly monstrous. Some, like the one in galaxy M87, weigh several billion times more than the Sun. The Event Horizon Telescope's first image in 2019 revealed M87's black hole as a glowing ring around a shadow, an image that captured the attention of the world. Its jet, visible even through ordinary telescopes, stretches for thousands of light years, a silent beam of energy threading the darkness. Though they consume, black holes also create. Their gravity helps organize galaxies, pulling stars and gas into coherent structures. The collisions and mergers of galaxies often bring their central black holes together, forming binary pairs that orbit for millions of years before merging in a final burst of gravitational waves. These ripples in space-time, first detected in 2015, confirm what Einstein predicted a century ago, that the universe itself can vibrate like a vast, invisible ocean. Gravitational waves from merging black holes pass through everything, through stars, planets, even you stretching and squeezing space so slightly that only the most sensitive instruments can detect them. Each wave tells the story of a collision that happened billions of years ago, echoing across time and distance. The paradox of black holes is that though they represent darkness, they illuminate the universe. They are among the most powerful sources of light and energy, and through them we learn about gravity, matter, and time itself. Near a black hole, time slows down a second. For someone close to the event horizon might equal centuries for someone far away. To fall toward a black hole is to fall through time, never to return. Yet, to an outside observer, you would never quite vanish. Your light would stretch and fade, frozen forever at the edge. Black holes also reveal one of nature's greatest mysteries, the link between gravity and quantum mechanics. At their core, the laws of physics, as we know them, break down. Beyond the event horizon, no one knows what truly exists. Perhaps matter collapses into a point. Perhaps it tunnels into another universe. Perhaps, as some physicists suggest, black holes store information on their surfaces, a cosmic library of everything they've ever consumed. In this mystery lies beauty. Black holes remind us that even in an age of science and measurement, the universe still holds secrets beyond understanding. They are not just voids, but symbols of cosmic balance, places where energy, time, and matter reach their limits, where creation and destruction become one. As you drift to sleep, imagine floating near a black hole, watching its glowing ring of light spin in silence. The stars curve around it, their paths bent by gravity. You can feel time stretch and slow, every moment infinite. Nothing here moves fast, yet everything moves forever. The pull is gentle, inevitable, eternal. The black hole hums quietly, feeding on light, shaping the galaxy, whispering its power through the silence of space. You drift away slowly, carried by the same gravity that binds stars to galaxies, galaxies to clusters, and clusters to the cosmic web. In that web, every black hole, every star, every world is connected, all part of the same structure, the same story. And though they are born in darkness, black holes give meaning to light. They remind us that even the void has purpose, that even silence can shape the universe. In their shadow lies understanding, and in their gravity, the heartbeat of creation continues slow, endless, and beautifully still. The invisible matter, dark matter, the hidden framework of the cosmos, we cannot see it, we cannot touch it, yet it is everywhere. It surrounds every galaxy, fills every cluster, and stretches across the universe like an unseen skeleton. It neither shines nor absorbs light, but its gravity shapes everything from the formation of stars to the very structure of the universe. Without it, galaxies would not hold together, and the night sky as we know it would not exist. Dark matter is the silent architect of the cosmos. The story of dark matter began not with discovery, but with confusion. In the early 20th century, astronomers began to notice that galaxies were behaving strangely. Stars far from the centers of galaxies were orbiting faster than they should have, according to visible matter alone. By all known laws of gravity, these galaxies should have flown apart, yet they held together. Something unseen, something massive was keeping them bound. In the 1,930 seconds, a Swiss astronomer named Fritz Zwicky studied the Coma cluster of galaxies and found that the visible stars and gas accounted for only a tiny fraction of its total mass. He proposed the existence of dunkle materie, dark matter, an invisible substance providing the missing mass. At first, few believed him, but over the decades, more evidence began to appear. Every measurement, every observation pointed to the same conclusion. Most of the universe is made of something we cannot see. Dark matter does not emit light, and it does not interact with ordinary matter except through gravity. This makes it nearly impossible to detect directly. We know it exists only because of its gravitational effects, the way it bends light, the way it shapes galaxies, the way it holds the universe together like a cosmic glue. If you could see dark matter, the universe would look utterly different. Galaxies would not appear as isolated disks of light, but as bright cores embedded in vast, invisible halos. These halos extend far beyond the visible stars, containing most of a galaxy's mass. Within them, dark matter's gravity pulls ordinary matter into clumps, creating the conditions necessary for stars and galaxies to form. Without these halos, the early universe might have remained a uniform fog of gas, never collapsing into the cosmic structures we see today. Astronomers have mapped dark matter indirectly through a technique called gravitational lensing. According to Einstein's theory of general relativity, gravity bends the path of light. When light from a distant galaxy passes near a massive object like a cluster filled with dark matter, its path is distorted, creating arcs and stretched images in the sky. By studying these distortions, scientists can map where dark matter lies, even though it is invisible. The results are astonishing. Entire webs of dark matter stretch across the universe, connecting galaxies like threads of silk in a cosmic tapestry. This cosmic web is the true structure of the universe. Visible galaxies trace its outline, glowing along the filaments of dark matter. At the intersections, the nodes of this web lie galaxy clusters, massive knots where gravity is strongest. Between them are vast voids, almost empty of matter. It is a structure both grand and delicate, shaped over billions of years by forces we barely understand. Scientists estimate that dark matter makes up about 27% of the total content of the universe. Ordinary matter, everything we can see, accounts for less than 5%. The rest, a mysterious force called dark energy, drives the expansion of the cosmos. That means nearly everything we experience, stars, planets, dust, and ourselves, is only a small fraction of reality. Most of the universe is invisible, silent, and hidden from view. So what is dark matter made of? We do not yet know. It is not made of atoms or light. It might consist of exotic particles that rarely interact with normal matter candidates like WIMPs, weakly interacting massive particles, axions, or sterile neutrinos. Vast underground detectors, shielded from cosmic rays, sit in silence, waiting for the faintest interaction. So far, none has been found. But the search continues, because to find dark matter is to uncover the universe's foundation. In some galaxies, dark matter reveals itself through motion. Dwarf galaxies, for example, are held together almost entirely by dark matter. Their visible stars are few, but their rotation speeds show that an enormous invisible mass surrounds them. In galaxy clusters, dark matter's presence can be measured by its gravitational pull on hot gas and by the lensing of background galaxies. Even in the cosmic microwave background, the afterglow of the Big Bang, faint imprints of dark matter can be seen, woven into the early structure of the universe. Dark matter is not uniform. It clumps and gathers, forming halos and filaments. Within those structures, ordinary matter collects and cools, creating the stars and planets that make galaxies visible. In this way, dark matter acts as scaffolding the invisible frame on which the luminous universe is built. If dark matter were to disappear, the galaxies would unravel. Stars at the edges would drift away into space. Clusters would dissolve. The cosmic web would collapse. The universe's great architecture would fall apart, leaving only isolated pockets of light fading into darkness. Dark matter's gravity holds it all together, quiet, unseen, indispensable. Though we cannot see it, we feel its influence everywhere. Every orbit, every cluster, every cosmic structure moves in response to its pull. We are surrounded by it, bathed in it, made safe by its gravity. Even here, in this very moment, trillions of dark matter particles are passing through you, ghostly and silent, leaving no trace. As you close your eyes, imagine the universe as a vast web, glowing faintly in the dark. The bright nodes are galaxies, but the strands between them invisible, endless, are dark matter. It stretches across billions of light years, forming bridges between the stars. It holds the universe together like a hand cradling all existence. In this unseen architecture lies peace. No movement is wasted, no light is lost. Dark matter is the quiet balance to the brilliance of the stars, the invisible counterpart to creation. As you drift to sleep, picture yourself floating within that web. The galaxies shimmer faintly around you, anchored by unseen forces. You can feel the pull, gentle and constant, guiding everything toward harmony. You realize of the universe, unlike dark matter, which holds galaxies together, dark energy pushes them apart. It is the mysterious force driving the expansion of the cosmos, stretching the space between galaxies faster and faster with every passing moment. Invisible, untouchable, and omnipresent, dark energy is the single most dominant component of existence, yet we know almost nothing about it. It makes up nearly 70% of everything, and it controls the fate of the universe itself. To understand dark energy, we must travel back to the beginning, to the first moments after the Big Bang. The universe began in a blinding explosion of energy and expansion. For billions of years, gravity born from matter and dark matter worked to slow this expansion down. Galaxies formed, clustered, and pulled on each other with immense force. For a long time, scientists believed that this slowing would continue, and perhaps one day, the universe might even collapse in on itself, a big crunch. But in 1998, astronomers studying distant supernovae made a discovery that changed everything. By measuring the light from exploding stars billions of light years away, they found that those galaxies were not slowing down, they were speeding up. The expansion of the universe was accelerating. Something unseen was overpowering gravity, pushing galaxies apart faster and faster. This unknown force was named dark energy. Dark energy does not behave like anything we know. It doesn't cluster like matter. It doesn't weaken over distance. Instead, it fills space uniformly, a property of the vacuum itself. It may be the energy of empty space, the cosmological constant Einstein once included in his equations of general relativity. He introduced it reluctantly to keep the universe static, not realizing that the cosmos was expanding. He later called it his greatest blunder. But perhaps he was right. The cosmological constant might be real after all, an ever-present force woven into the fabric of reality. In our own cosmic neighborhood, the local group galaxies like the Milky Way and Andromeda remain gravitationally bound. Dark energy cannot tear apart things held tightly by gravity, but beyond our cluster, galaxies are drifting away into darkness. One day, billions of years from now, their light will fade beyond reach. The universe will continue expanding, and we will be left in a cosmic island, a small oasis, surrounded by eternal night. The far future of the universe depends on dark energy's nature. If it remains constant, as the cosmological constant suggests, the cosmos will expand forever, cooling, dimming, growing more empty. Stars will die, galaxies will fade, and the universe will drift into silence, a scenario known as the heat death. If dark energy grows stronger with time, expansion will accelerate so much that even galaxies, stars, and atoms will be torn apart, a cataclysm called the Big Rip. But there is another possibility that dark energy could weaken or even reverse. In that case, gravity might one day regain control, pulling the universe back inward. Galaxies would collapse together in a fiery end, the Big Crunch, possibly followed by another expansion, another Big Bang. The universe could be cyclical, breathing in and out for eternity. Whichever fate awaits, we are living in a special era. Galaxies are still visible to us, their light still reaching our eyes. In the far future, that light will fade away as cosmic expansion stretches space beyond the limits of sight. Astronomers of that distant age, if any exist, will look into the sky and see only their own galaxy. They will never know that others once existed. The universe will seem small and quiet again, just as it did before we discovered its vastness. The largest galaxies in the universe, colossal cities of stars stretching millions of light years across, ancient and magnificent. These are not just galaxies. They are cosmic empires, built from countless mergers and collisions, glowing softly in the eternal dark. Where most galaxies, like our Milky Way, hold hundreds of billions of stars, these giants contain trillions. They are the titans of the cosmos, slow, luminous, and breathtaking in scale. The largest known galaxies are mostly elliptical in shape, massive, smooth, and golden. They do not have the delicate spiral arms seen in galaxies like ours. Instead, they are enormous orbs of light, filled with old stars, surrounded by vast halos of dark matter and gas. They live mostly in the centers of galaxy clusters, where gravity pulls everything inward, forming these cosmic monarchs through billions of years of galactic cannibalism. One of the most massive galaxies ever observed is IC 1101, located about 1 billion light-years away in the Abell 2029 cluster. It spans roughly 6 million light-years from edge to edge, more than 60 times the diameter of the Milky Way. If it were placed where our galaxy is, it would stretch beyond the Virgo cluster, engulfing dozens of galaxies within its radius. IC 1101 contains hundreds of trillions of stars. Its glow faint but immense, like a distant sunrise across eternity. Such galaxies are ancient. They formed early in the universe, growing slowly as smaller galaxies collided and merged into them. Every collision added more stars, more gas, and more dark matter, creating the vast, round shapes we see today. These giants no longer form many new stars. Their gas has been consumed or blown away long ago. What remains is a population of old, red stars that burn quietly, their light soft and steady. Around these giant ellipticals lies a halo of intracluster light, a faint glow created by stars, stripped from smaller galaxies. These orphan stars drift freely in the gravitational sea, no longer bound to any single system. If you could see this halo with your eyes, It would shimmer like fog, spreading for millions of light years around the central galaxy, a silent ocean of starlight. Within the centers of these enormous galaxies lie the most massive black holes in the universe. Some weigh tens of billions of times more than the Sun. Their gravity shapes the entire core, pulling stars into tight orbits and releasing immense energy as matter falls inward. In the galaxy M87, for instance, lies one such black hole, 6.5 billion solar masses strong. It powers a jet that shoots from the galaxy's core, extending for thousands of light years, glowing in radio waves and X-rays. This jet, seen even from Earth, is a symbol of raw galactic power. Galaxies like these often sit at the centers of clusters, vast gatherings of hundreds or thousands of galaxies bound by gravity. These clusters are surrounded by hot gas that glows in X-rays, and the central galaxy feeds on that gas like a cosmic monarch consuming its domain. Smaller galaxies spiral inward over time, torn apart by gravitational tides, their stars absorbed into the growing mass of the central giant. In this way, the largest galaxies are still growing, even now, long after their own star formation has slowed. But their size and beauty come with silence. Inside these giants, the average distance between stars is immense. The light may be bright from afar, but up close, the vast spaces between suns feel empty and cold. The stars here are old, ancient red giants and faded dwarfs, remnants of younger ages when star birth was common. In their quiet light, we see the passage of cosmic time written clearly, like wrinkles on the face of the universe. Not all giants are ellipticals. There are also enormous spiral galaxies, though they are rarer. One of the largest known is NGC 6872, a barred spiral galaxy stretching over 500,000 light years, nearly 5 times the size of the Milky Way. Its graceful arms curve outward like wings, shaped by a collision with a smaller galaxy nearby. Within its spirals, blue regions mark where new stars are still being born, making it a living contrast to the quiet giants of clusters. Another remarkable example is UGC 2885, sometimes called Rubin's Galaxy, named after the pioneering astronomer Vera Rubin. It is one of the largest spiral galaxies ever found, about 800,000 light years across, containing 1 trillion stars. Its disk spins with a perfect balance of motion and symmetry, its light stable and calm. Rubin's Galaxy is a masterpiece of cosmic engineering, vast and harmonious, shaped by the slow, deliberate forces of gravity. The largest galaxies are not just curiosities. They tell us how the universe evolved. Every giant began as smaller galaxies merging over time, forming the structures we see today. By studying them, astronomers can look back through cosmic history, tracing how gravity sculpted light into form. They are, in a sense, fossils of the universe, ancient monuments built from billions of years of cosmic activity. If you could float near one of these giants, the view would be beyond comprehension. The core would shine like a soft golden sunrise, surrounded by countless faint stars fading into the distance. There would be no edge, no clear boundary, just a slow thinning of light as it stretches into the black. Around you, the faint glow of the cluster's hot gas would shimmer like a halo, and beyond that, the darkness would return, infinite and silent. These galaxies are not chaotic, they are serene. They have seen countless ages of birth and destruction, and yet they remain massive, calm, eternal. Their light travels for billions of years to reach us, carrying with it the memory of every star, every merger, every moment of their existence. When we gaze at them through telescopes, we are not just looking at distant objects. We are seeing time itself, light that left before our world formed, before life began. Their slow glow reminds us of the universe's patience, its scale, its beauty. As you drift into sleep, imagine standing at the edge of one of these galactic giants. Before you stretches an ocean of light, soft and endless. The stars glow like embers in a fading fire, each one a story, a heartbeat of creation. In the stillness, you can feel the weight of time pressing gently, the quiet strength of gravity holding everything in place. The largest galaxies are not loud. They do not blaze with youth or motion. They simply are vast, ancient, and complete. Their light is the whisper of eternity, and their silence the song of the universe at rest. And as the night deepens, let that silence carry you. The giants of the cosmos drift through the void, their light reaching you across endless time. You are a witness to their stillness, a part of their story, a flicker of consciousness within the same universe that shaped them. And somewhere, in that quiet infinity, the galaxies continue to glow slowly, beautifully, forever. In the heart of each galaxy, the supermassive black holes begin to circle one another. At first, they orbit slowly, separated by light years. But as time passes, they spiral inward, pulled by their combined gravity. When they finally merge, they release a storm of gravitational waves ripples through space-time that travel across the universe. It is a silent event, yet it reshapes the very fabric of existence. One of the most famous galactic collisions in our nearby universe is the Antennae galaxies, located about 60 million light-years away. Once two separate spirals, they are now intertwined, their arms stretched into long, elegant streams of stars. The center glows with hundreds of young clusters, each containing thousands of massive blue stars. It is a cosmic masterpiece, chaotic yet perfectly balanced, the result of gravity's endless creativity. As you drift toward sleep, imagine watching two galaxies meet in the void. They approach slowly, their light touching before their matter does. Spirals intertwine, stars drift, colors bloom, and silence reigns. You are a witness to the most graceful destruction imaginable, a collision that brings not chaos, but beauty. In the vastness of space, even the greatest collisions are calm. They unfold like a breath, like a tide. And as galaxies merge and change, the universe reminds us of its truth, that every ending is only the beginning of something new, and that even in the quiet darkness, creation never stops. The great cosmic web, the universe's invisible structure, vast beyond imagination, stretching across hundreds of billions of light years. It is the true shape of the cosmos, the framework upon which all galaxies, clusters, and stars are arranged. From a distance far beyond any single galaxy, the universe reveals its design, a web of light and shadow, filaments of matter intertwined through the dark, connecting everything into one grand, living network. For much of human history, we saw the night sky as a flat dome, dotted with scattered stars. Even after discovering galaxies, we imagined them as isolated islands, adrift in endless emptiness. But as technology advanced and telescopes grew stronger, astronomers began to map the positions of thousands, then millions, of galaxies. What they found shattered the illusion of randomness. The universe was not a scatter of dots, but a pattern, a structure, a masterpiece of gravity. Galaxies were not spread evenly through space. They gathered in clusters, connected by filaments of invisible matter, and separated by immense voids, vast regions nearly empty of galaxies at all. Together, these threads and gaps form what is now called the cosmic web. It is the largest known structure in existence, the architecture of the universe itself. Each filament in this web is made of both dark matter and ordinary matter. Dark matter forms the invisible backbone, providing gravity that draws gas and galaxies into long thread-like chains. Along these threads, galaxies form like dewdrops, glowing softly against the darkness. Where filaments intersect, clusters of galaxies appear enormous nodes of light, where thousands of galaxies live close together, orbiting in complex motion. Between these intersections are the cosmic voids, enormous, silent expanses that span hundreds of millions of light years, nearly devoid of stars, a darkness deeper than any night. In some ways, the cosmic web mirrors patterns found in nature. Its design resembles neural networks in the brain, the mycelium threads of fungi beneath the earth, and the branching of rivers and trees. It is as if the same geometry repeats across scales, from microscopic life to the structure of the universe itself. The cosmos, vast and silent, follows the same rhythm found in the smallest forms of life. If you could drift through the cosmic web, the view would be beyond imagination. Around you, threads of light would stretch in every direction, faint rivers of galaxies flowing through the black. In the distance, enormous clusters would blaze like constellations, while vast, empty voids would open between them, silent and endless. You would feel the presence of invisible dark matter shaping everything. Though you could not see it, the scale would be so immense that even light would take billions of years to cross from one filament to another. And yet, within this immensity, there is connection. Every galaxy, every star, every atom of matter is part of this network. The light that shines in your sky tonight came from one of those filaments, carried through the web like a message from the universe itself. You are, quite literally, made from the same material that threads through that structure, the same atoms, the same physics, the same origins. As you close your eyes and drift toward rest, imagine floating through this cosmic web. The stars around you fade into filaments, the galaxies into glowing threads. There is no sound, no movement. You can feel only the slow pulse of gravity, drawing everything together. You move along one of the filaments, crossing through clusters, passing by galaxies and voids, gliding endlessly through the woven light of the cosmos. The great cosmic web is not chaos. It is harmony, on a scale beyond comprehension. Every filament, every node, every empty space has purpose. It connects everything that exists, galaxies, stars, planets, life, into one vast whole. In the stillness of space, the web stretches quietly, growing with time, carrying the universe forward. And as you sleep beneath the same stars, you are part of that web, a single, luminous point in an infinite design, connected to everything, bound by the same gentle gravity that holds the cosmos together forever. As technology advanced, telescopes became not just bigger but smarter. On Mount Palomar, the 200-inch Hale telescope captured deep, clear images of distant galaxies. Later, space telescopes lifted our vision above the distortions of Earth's atmosphere. The Hubble Space Telescope, launched in 1990, revealed the universe in breathtaking detail. Its deep-field images, long exposures of seemingly empty patches of sky, revealed thousands of galaxies in a single frame, each one filled with stars, planets, and possibilities. For the first time, we could see back in time, not metaphorically, but literally, because light takes time to travel. Looking farther into space means looking farther into the past. The faintest galaxies in those images are so distant that their light began its journey billions of years ago, when the universe was young. Every telescope is a time machine, capturing ancient photons that have traveled across eons to tell their story. With the arrival of the James Webb Space Telescope, our view has deepened even further. Webb peers into the infrared wavelengths invisible to the human eye, but perfect for seeing through cosmic dust and detecting the faint light of the earliest galaxies. Geo telescopes, like the great dishes of the Very Large Array in New Mexico, detect long wavelengths from cold gas clouds and pulsars. X-ray telescopes, such as Chandra, reveal high-energy phenomena, the glow of black holes and supernova remnants. Infrared telescopes like Webb show us the heat of dust and newborn stars. Each one adds another color to the universe's invisible spectrum, together painting the full picture of the cosmos. On Earth, observatories stand atop mountains and deserts, far from city lights in Hawaii, Chile, the Canary Islands. There, under perfect darkness, immense telescopes gaze into the past. They capture light so faint, it has crossed billions of light years just to touch a mirror for a fraction of a second. In that brief moment, the universe speaks, and we listen. Even amateur astronomers, with smaller telescopes, can glimpse galaxies' faint smudges that hint at the immensity beyond. To look through a telescope is to experience both humility and connection. In that small circle of glass, you see what no human eye saw for thousands of years, the faint glow of another world, another time, another galaxy. Future telescopes promise even greater discoveries. Projects like the Vera C, Rubin Observatory, Nancy Grace Roman Space Telescope, an extremely large telescope will map the universe in detail never before imagined. They will count billions of galaxies, detect planets around distant stars, and perhaps glimpse signs of life in the atmospheres of alien worlds. Each advance brings us closer to answering the oldest questions: where we came from, what the universe is made of, and whether we are alone. But beyond the science, there is something deeply human in the act of looking outward. Every telescope ever built is a reflection of our curiosity, our longing to understand what lies beyond the horizon. Each time we build a bigger lens, we are not just searching for galaxies, we are searching for meaning. As you lie in the quiet of night, imagine the telescopes scattered across the world and drifting through space, their mirrors catching the faintest light from distant galaxies. Imagine that light, ancient, fragile, and pure, finally reaching us after billions of years. Through those beams, the universe speaks in silence, telling stories of birth and death, of creation and time. You are part of that story. The same light that passes through a telescope tonight has touched the atoms that make up your body. You are made of the same elements the telescopes are observing, born from the same stars. As you drift into sleep, think of the telescope still awake, listening, watching, capturing the whispers of the cosmos. Above you, the universe continues to shine, and through our instruments of glass and metal, we continue to reach for it. The light travels endlessly. The lenses gather it gently, and together, we see not just the galaxies, but ourselves reflected in their glow. One of the most famous and nearest clusters to us is the Virgo cluster, located about 54 million light years away. It contains over 1,300 galaxies, each one a world unto itself. At its core sits the giant galaxy M87, home to the supermassive black hole that was the first ever photographed. Jets of plasma stream from its center, stretching thousands of light years, lighting up the surrounding space like cosmic lighthouses. The Virgo cluster is not just nearby. It is part of a much larger structure known as the Virgo supercluster, which also includes our own Milky Way. We too belong to a cluster, though a much smaller one. Our galaxy is part of the local group, a modest gathering of around 50 galaxies, including Andromeda, the Triangulum Galaxy, and dozens of dwarfs. Together, we orbit within the outskirts of the Virgo supercluster, connected by the same invisible gravitational threads that bind all of space. Larger clusters, however, are true giants. The Coma cluster, for instance, lies 320 million light years away and holds thousands of galaxies moving at incredible speeds, up to 1,000 kilometers per second. The cluster is surrounded by a vast halo of hot gas, glowing in X-rays, heated to tens of millions of degrees. Though the galaxies are beautiful, this searing gas actually contains more mass than all the stars combined. It is the glue that holds the cluster together. Its heat, a reminder of the violence of cosmic formation. Through telescopes like Chandra and Hubble, we've seen clusters in exquisite detail. The Bullet cluster, in particular, offers extraordinary insight. It formed from the collision of two galaxy clusters, passing through one another like ghosts. The galaxies barely touched the space between them, too vast, but their dark matter halos collided and separated from the hot gas. By studying this event, scientists confirmed that dark matter exists, visible only through its gravitational lensing of light. Gravitational lensing is one of the most stunning effects in galaxy clusters. When light from a more distant galaxy passes near a cluster, the cluster's immense gravity bends it, magnifying and distorting it into arcs and rings. In deep images, you can see these luminous streaks surrounding the clusters, the stretched echoes of faraway galaxies, their light twisted by gravity into shapes that seem drawn by hand. This phenomenon allows astronomers to see galaxies billions of light years farther than they otherwise could. Nature's own telescope, sculpted by the universe. Clusters are not static places. They are filled with motion and energy. Galaxies within them constantly move, pulled toward the center by gravity. They collide, merge, and sometimes are torn apart by tidal forces. Smaller clusters combine into larger ones, forming superclusters, massive structures that span hundreds of millions of light years. Each merger sends shock waves through the surrounding gas, heating it further and lighting up the cluster in X-rays. In the largest scales, clusters connect to one another through filaments of the cosmic web, forming the skeleton of the universe. Between these filaments are enormous voids, vast spaces where galaxies are scarce. Together, these clusters and voids create the universe's large-scale pattern, a delicate, interconnected network that mirrors both chaos and order. Scientists have discovered that even clusters themselves are not the end of structure. They group into superclusters, which then link into even greater formations. Our own Virgo supercluster, for example, is part of a still larger region called Laniakea, meaning immense heaven in Hawaiian. Laniakea contains over 100,000 galaxies, spanning 520 million light years. At its heart lies a gravitational center, a mysterious region called the Great Attractor, which pulls entire clusters, including ours, gently toward it. To imagine a galaxy cluster is to imagine a night sky filled not with stars, but with entire galaxies. If you could stand within one, you would see hundreds of glowing spirals and ellipticals surrounding you, each one brighter than the full moon. Some would collide and merge before your eyes, though the process would take millions of years. The space between them would shimmer faintly with the glow of hot gas and the invisible presence of dark matter. It would be both magnificent and humbling, a true city of light floating in an ocean of black. Over time, as dark energy continues to expand the universe, these clusters will drift farther apart. One day, billions of years from now, even neighboring clusters will be beyond reach, their light redshifted into oblivion. The galaxies within each cluster will remain bound together, but the universe will become an archipelago of isolated islands, each drifting alone through darkness. Yet for now, they remain connected, vast cities of galaxies glowing softly in the night, linked by gravity and history. In them lies the story of creation, collision, and balance. They are the places where galaxies find company, where stars are born, and where cosmic evolution plays out on the grandest stage imaginable. As you close your eyes and drift into sleep, imagine floating through one of these clusters. The light of 1,000 galaxies surrounds you, golden and blue, flickering gently. The silence is perfect, but alive, filled with the hum of gravity and the quiet pulse of eternity. You drift between spirals and ellipticals, between newborn stars and ancient giants, surrounded by light older than time. The clusters do not speak, but they tell a story of unity in vastness, of connection across emptiness. of beauty born from gravity's embrace. And as you float among them, you feel it too, the quiet comfort that even in the greatest darkness, there is always light, and that light is endless. In this era, there will be no more stars, no galaxies, no light, only particles drifting endlessly through the cold void, so far apart that they will rarely, if ever, collide. Space itself will continue to expand, stretching matter thinner and thinner, until even the memory of galaxies is lost. Time will go on, but nothing new will happen. It will be a universe of silence, vast and empty, not dying, but resting. And yet, within this stillness, there is peace. Every galaxy that ever existed, every light that ever shone, will have played its part. The atoms that once burned in stars will still exist, scattered across infinity. The universe will not end in fire or destruction, but in quiet and endless calm after the brilliance of creation. But that is not the end of meaning, because even now, long before that far future, galaxies still shine. The stars still burn, nebulae still breathe, and black holes still sing their deep songs of gravity. We live in a golden moment, a time when the universe is still alive with light, when galaxies can still be seen, still studied, still loved. As you gaze at the stars tonight, you are looking at a universe in motion, one that is still expanding, still creating, still telling its story. Every point of light you see is a moment of that story, traveling across billions of years to reach you. The Milky Way, the Andromeda, the countless galaxies beyond all are part of a grand narrative that stretches from the birth of time to its quiet end. And when you think of that end, when all galaxies are gone, remember that it is not a tragedy, but a completion. The universe has no beginning without an ending, no creation without transformation. Even in darkness, it remains what it has always been: beautiful, mysterious, and infinite. As you close your eyes, imagine the galaxies drifting apart, their lights slowly fading into the horizon of time. Feel the stillness that comes after eons of motion, a silence so deep that even time seems to pause. Yet within that silence, there is serenity, a cosmic calm that carries everything, everywhere, forever. The fate of galaxies is the fate of all things: to shine, to fade, and to become one with the universe once more. The light you see tonight is ancient, and one day, it too will rest. But for now, it shines, and in its glow, you are part of something eternal. So sleep gently beneath that light, for it connects you to everything that ever was and everything that ever will be. The galaxies will fade, but their memory will linger not just in the stars, but in you, the child of their light, dreaming in the quiet heart of the cosmos.